I know we understand at Advantage Learn how precious educators' time is and how stretched your time is. So thank you for taking the time to join us this afternoon for our next Neo Series Educator Session. We're really excited to have Simon Holderness on the panel this afternoon to give us a keynote, and then also to have Trish Pike share her knowledge with us later afterwards. So essentially what these sessions are all about is about knowledge sharing in the maths domain and giving maths educators in South Africa an opportunity to learn from some of the experienced minds in the field, and to give educators a space to share and a space to develop one another. So like I said, we're really excited to have Simon Holderness on this afternoon. He's currently the Deputy Head of Pupil Affairs at the Diocesan School for Girls in Grahamstown. And he's, as many of you will know, he's been the IEB examiner for quite some time, if we've got our facts correct, from 2015 to 2023, spanning both paper 1 and paper 2. And his term as examiner, I think, ended at the end of last year with him setting his last paper. He's an incredibly experienced maths educator with over 2 decades of maths teaching experience. And I really think it's going to be very insightful and helpful for us to hear from him and how he approaches the subject in his classrooms. So here to tell us about how you make your maths students arrive early and stay late, Simon's going to take over now and tell us all about that. So over to you, Simon.
Yeah, thank you very much for the introduction. That is very kind of you. Look, so really just let me start by saying good afternoon to everyone and welcome. It really is like a real privilege to be asked to come and present today. So thank you very much for the opportunity. And I think I was going to start by saying the things I hope you get out of this presentation. And I think, I've been to a lot of these things, but I really hope you can take a practical takeaway. And that's going to be the sort of the core of this presentation, with a few other ideas and kind of a few things just to kind of activate your brain and maybe to get you thinking. I think that's really where I'm going to start. The title of my presentation, Arriving Early, Staying Late, is probably came from one of those moments, and I think we've all had it, when you're standing at your board and you're doing that distributive law, and it's sort of 2 o'clock in the afternoon, and you're doing the, that good old rainbow board work. And there was a moment where I actually almost fell asleep in my own lesson. And I thought to myself, if I'm feeling like this, what do the kids feel like? And it was that kind of moment when I thought, I've got to actually try some different stuff. And I suppose it got me thinking a bit about sort of what do kids engage with nowadays, and it's obviously IT based, but I've always had a worry about this consumerism kind of concept where kids find apps, use them, but there's not much thinking that goes in behind it. So I took a dive one day and I thought, let me try something out. And I'd been playing around a lot with Excel myself, and I actually really got into it. Really started to enjoy it. And I thought, well, surely we can get kids involved with this. I mean, they would, it's something that actually almost brings maths to life. So I'm just going to quickly just shift the slide on here. Okay, so that is really one of the kind of projects I gave to my class. I said, I want you to build an app that helps explain the nature of roots by sketching a parabola and linking this to the discriminant. And the notes were quite simple. It must be functional and it must be attractive. And that, a simple piece of work like that takes a lot of thinking, actually. And I'm going to take you through 6 phases that I think you can show your kids, and then you can let them loose, and they'll come up with things that you'll be amazed at what they pull out of the bag. So I'm going to just quickly exit this particular PowerPoint presentation quickly. Right. Can everyone see that? Okay, great. Okay, so I've pretty much taken the idea of what is required to build an app of that nature, and I've broken it down to 6 phases. So I've got, if you look at the tabs along the bottom, I've got phase 1, phase 2, phase 3. I'm going to take you through each one quite quickly, and then obviously I think it is being recorded, so you can always go back and look at a few things if you'd like to. And this is the kind of information you can share with your kids. Some of you, this is going to be very boring initially for some parts, but you might learn a few things along the way. So it's not the Excel skills that are really what I want to show you. It's more the kind of process you can take your kids through, and how you can build a lesson of this nature for them. Okay, So phase one, a lot of kids, this would be kind of the 4 steps that I would show the kids. Quite simply, creating X values. So if I create a column of X values, let's say starting at -10, -9, and you will know if you do Excel, you can drag this down, and we can create X values from -10 all the way down to 10. You can use as many as you want. And then it's really on how do we generate a Y value. So we want to apply a simple calculation to the X value. Let's just create a Y equals X squared. So I want to square every X value. So if you use Excel, you would know that if you use equals, starts the formula. I would like to square the value in A7. You'll notice that that funny little sign is square, and we should get a value of 100. And I would continue this the whole way down in column B, and I can drag it down. And you can double check your values. -9, 80 gives you 81, 64, etc., etc. Okay, so we've created now a whole set of points. Step 3, how do you take this and put it into a graph format? So with I can highlight the 2 columns, the X and the Y values, and I highlight the 2 columns. And if you look across the top here, you'll find the insert button, and we're going to insert a type of chart. Now, the chart that works best for this type of work is the scatter plot. We don't want that. We don't really want that. We probably want to use that format. Okay, so we can create the shape that has been developed. So we've obviously got a basic parabola. And then I always show them step 4, and I'll explain it later, but the chart title, you can delete that. That doesn't look great. And you'll notice here that your Y value, your Y axis is from 0 to 120. So what I like to do is set that. So if you click on that and right click, you can format the axes, and you can have the axes run from a minimum to a maximum value. So let me run it from, let's just keep it simple. We'll just run it from minus 20 to 20 and leave it like that. And you'll notice suddenly now that your Y axis runs from -20 to 20. And I'll do the same with my X. I also format my X axis. I put them in, I pretty much base it on the X values I've inputted on the left-hand side. So I'm going to run it from -10 to 10. And you can play around with it a bit, but they get this fairly quickly. Okay. So now I've drawn the shape, linking based on these values over here. That'll be my phase 1. Any questions at this stage, or is everyone happy to move on? All good. Okay. Phase 2. We sort of increase the kind of, I suppose, the technicality around it, but we still run our -10 to 10. So we create some X values. Yeah, and we show the kids that once again, you can drag it down. But now to generate a Y value, I want to sort of show you a basic formula. So I want to square the value now, square my X value, and I want to add on the number in the yellow block. So let's call it 5. Okay, so I'm going to say equals to A7, which refers to that cell, and the X value I want to input. I want to square that value. That gives me 100. But now I want to add on this the number in the yellow block. So I'm going to push plus E10, and you get 105. Now, if I drag this down 1, I'm expecting the answer to be -9 squared, which would be the 81, plus the 5, which is 86. But you'll notice I get a value of 81. So what's happened here is when I drag this formula down, for those of you aren't too aware with of Excel, it takes this E10 and it makes it E11. So the best way of doing this is if you put a $sign in front of the E and a $sign in front of the 10, it locks those 2 values. So when you drag it down, this should give you a value of 86 now. And you'll notice now if I drag this the whole way down, I've now squared the number and added 5 to every single one. So the formula, the only thing that changes, if you look in the, what would we call this? the formula bar. Yeah, if I scroll down, the only thing that's going to change is the X value, that A7 becomes A8, A9, but the E10 remains fixed. Quite an important concept to teach. Okay. That's that. Phase 2 done. Then we want to phase 3. And this is something that I really think kids love. And I think that the way of that's sort of starting to get them to think about if-then statements, which is a very powerful kind of way of thinking in terms of logic. So once you've seen how this works, it becomes fairly easy. So if I would like to take this note 1, you'll see it reads there. If A3 is equal to 1, so that's referring to the green block, then it will say I love maths, and then anything that appears afterwards it'll be if it is not 1. So it's if it is true, it'll return the first bit of information, which is I love maths, and if it is not true, it'll then use still deciding. So if I write that in here, equals if A3 semicolon exclamation mark I, and you can write whatever you would like in here. It will return whatever's written between the 2 exclamation marks, comma, still deciding. If I put a 1 in here and I push enter, it should change it to I love maths. So if I put a 2 and I enter, there's a problem now. What have I done here? Okay,
in the formula, we haven't put A3 equals 1 there. That's where
there we go. Thank you very much for picking that up. Okay, and that's also one of the beauties of this thing. If you find a kid who's suddenly saying, "Sir, it's not working," you can give him my friend, listen, it's never really the machine, it's actually the person entering it. So they like to work it out. Okay, so if I change it to a 2 now, it should change to still deciding, or a 3 or a 1. And you can see the power of this. Okay, and we'll talk about that now. Okay, they love that. Then we take note 2. Okay, and now we've got A7 greater than 0. So if A7 is greater than 0, we would like it to return a value of a positive. Otherwise, we would like you to return a value of a negative. Okay, so if I put a number here of 2, it's greater than 0, it should put a plus. 4, if I put a negative 5 in here, it should change it to a negative. Yeah, I hope that's all making sense. And you can always go back and play around with this yourself, but once you start working it out, it is pretty simple. Okay, but it's a really important phase in allowing kids to develop this app. Okay, phase 4. This is really where the kids really, and I think this is what's important about arriving early and leaving late. This is where they can be creative. You start to you give them that story about there's 100 people who developed this app. Which one of you is going to sell this to 1 million people for R1? You know, it's not going to be 2 of you, it's going to be 1 of you. You're pitching to someone. Why is yours going to be the best? It's not often, it's got to function, of course, but it's got to look and feel the best. And that's when they really start to kind of engage. They love this. And often it's not your top math student who makes it look and feel the best, actually. It's someone with something else in there. So it's quite an interesting thing. Okay, so what we do here is I like to show them that if I want to try and get it to look like this, y equals ax squared plus bx, what I'm trying to explain to them is that you need a y equals, okay? You need a number, which is your value for a, just for now. You can make an x squared here. So they write x squared, you can highlight the 2 in the cell. But I've also discovered what I've been doing with Excel. If you ask the question, it'll probably be able to there'll be a way of doing it. Superscript. Okay, so now we've got an x squared. You need a space for a plus. Don't worry about that too much. A value for b. Then there's an x. Let's put a plus there for now. And a value of 4. Okay. So let's put a number in here for now, 3x squared plus 2x plus 4. And it doesn't look great at the moment, but suddenly they can, maybe change the font size. They start to realize, actually, hang on, let me just make that a bit smaller there. And suddenly you've got something that looks like an equation. And you've got the ability to create a function, to make it functional, because you've isolated the value of A and B and C in a single cell, which is quite an important concept. Okay, so you play around with this a bit. Right, there we go. Phase 5, we introduce them to the scroller, and it's one of those things that if you haven't been shown this, you never really find it. Okay, so there's something called the developer tab. If you look at the top of the spreadsheet here, you've got file, home, insert, layout, formulas, data, and there's a developer tab here. If you do not have that, you can follow the prompts. You'd go to file, options, down the left. There's something called customize ribbon. And you'll notice here there's a little, this is often not ticked. If it's not selected, it won't appear. So make sure that it's selected. You push OK, and your developer tab comes into play. Now this is where you start to make this thing look alive. So here with your developer tab, you're going to find this insert. I have put it down here in step 2, and you click on the scroller option, which is this one over here. Yeah, and you've suddenly now got this big arrow that it's like a button. Okay. Now you'll see in step 4, I've said to you, learn how to use 2 cells to create a negative number. And also in step 3, it says, learn how to link this to a particular cell. So if I right click on my scroller, you can go to format control, and there's a cell link. So I want to link this to F7. So what it means is that this particular scroller is going to work the cell F7 up and down. You'll notice that it can't go below 0, which I found very frustrating. But you can problem solve a bit around this. So if you put -10 below the 0, and you have a third cell where you say equals to F8 plus F7, you can suddenly now create a number that goes down to a lowest value of 10, of -10. It's a strange thing. I don't know why they didn't have a negative value, but that's a way around it. So I always like to show the kids that, and they really enjoyed this. Okay, that's phase 5. And then we start to bring it all together a bit. Well, okay, let's just take phase 6, and then we'll bring it all together. Okay, so phase 6 was just creating a simple formula. So if I take a y equals to 3, and let's have, I'm actually going to copy it from the other one quickly. This look and feel. If I take this quickly, yeah, I'll copy it across to my phase 6. Okay. I've got the value of A is 3, the value here. I can work out my discriminant, a little formula here. Sorry, just going to increase that. And I'm going to generate a value. So it's going to equal to my B squared, okay, which is going to be my F8. And we're going to have to we have to work this out just now. Minus, sorry, I'm going to have to square that, just remind me. B squared minus 4 times by, Trish, I am doing the right thing, eh? Times by C8 times by my value for C, which would be my I8. Okay, so I get a value of -44. Let's take a perfect square, and there's my value for 0. Okay, my roots are equal. It's quite nice here, and if you've got some top kids, they will start to say, oh, hang on a second. If C11 equals to 0, then I wanted to say roots are equal. And otherwise, you can leave it blank, and I'll explain how you do that. You just put 2 inverted commas together. So now if I change this over here to a 2, or if I've got a plus 9x, let's make it a bit easier, plus 10x plus 25, yeah, we're starting to create a bit of if-then statements. What happens if this is the answer? And that is quite a powerful thing. It's simple to us as maths teachers, but for a kid to actually start to think about that already, and put it together, There's a lot of thought that actually goes behind it for them. Okay, right. So now we take all of those phases and you ask, you can actually show them a bit, and then they can actually go back and do it on their own. But we're going to put it all together. So I call it like the blank canvas concept. And I think this is important. And I try and equate it to art. A person who produces a piece of art, it takes a lot, it's a lot of your own creative thinking. And when you go and to physically put it up and people to look at, that is quite a moment actually. And when kids start to see that the maths is coming alive, this is their work, this is their creation, they've put a lot of effort into it. So I'm going to just take you through what you can create quickly. So I'm going to develop an app. It won't take me long. So let's quickly just do okay, so let's take the formula. We're going to have a value for a there. We're going to have an x squared. Superscript that quickly. Sorry, it didn't take 2 seconds. There we go. Okay, I'm going to have a value here. And I'm going to show you just 1 or 2 sneaky tricks. It's there, and a value here. Okay. So I'm just going to give them a different color so you know what I'm referring to. Okay, right. Now what I learned with Excel is to create a good look and feel, you actually need to put numbers, the working has to happen below the actual, what this thing looks like. So I would like to introduce a scroller that changes the value of A. Okay, so the skill they learned there was that they would like A to, let's take a minimum value of -10. What's happening there? Okay. I want the scroller to be linked to B5. So if I scroll here, what have I done now? Apologies, there's something funny here. I think it's the font color. There we go. Okay. And then I can have a value that appears here, which is going to be my B5 plus my B6. Okay, so that's the important value. That value below the purple block is actually my value for A. That's the one I'm going to refer to at all times. So in this particular case, I'm going to write equals to B4. And that's what appears there. Okay, quite simple. You can actually copy one of these scrollers. Apologies, it will happen now. Okay, it's not working. I'm just going to insert another one. Yeah. And now you need to this is where it becomes quite interesting. I have a -10. I'm going to link this to D5, which is there. And I'm going to create a value here in D4, which is going to equal to D5 plus D6. Okay, so that's the value of my B. Now, what I want it to look like, I need to split the negative and the 4. And this is quite an interesting discussion with kids, actually. So in the green block, I wanted to, I can't put a -4 there. I wanted to return a +4. So in Excel, you've got the absolute value of, and we had the cell B4, I think it was. No, I'm talking rubbish. D4, not B4. So that is the absolute value. And it's quite a nice discussion. They ask, what is the absolute value? And even though it's not really in the syllabus, it is quite nice to talk about it. And then D3, we can go, if D4 is less than 0, then I would like you to show me a negative. Otherwise, show me a positive. Yeah, so now it starts to look quite nice. So as I scroll here, you'll see what happens. Sort of all changes. So starting to get a sort of app sort of feel about it. Do the same thing here. So I'll get moving as quickly as I can. Okay, we do the same for the value of C. So I put a -10 here. I'm going to link this cell to G5. And I'm going to have this. It's going to equal to G6 plus G5. Okay. And I'll do exactly the same thing as I did with the 2. So in the yellow block, I want the absolute value of G4. So it returns a positive 7. And in the blue block, if G4 is less than 0, I would like to return a negative value. Otherwise, it must return a positive value. Okay. So this, you can double check if it's working. Okay, so now I've got this kind of thing that looks like it's working. Okay, now we go back to what we did in phase 1. I'm going to generate a whole lot of x values, minus 10 to 10. Minus 9, so this is all the stuff that's kind of creeping up. Drag it. And drag that down. And I should get minus 10 to 10. And then I want to apply this particular, to generate my y value, I want to use this formula here to create my y value. And the important numbers to remember are these ones in orange, A, B, and C. Right, so to get my y value, I'm going to say it equals to B4, and I'm going to lock this one because it doesn't change. Apologies, where the problem is. I just want to quickly just, okay, equals to B4 times by, now the value of x is going to be an A13, so it's going to be A13 squared plus the value in D4 times by the x value, which is still going to be A13, but I am going to have a slight problem here because I haven't locked the D and the 4. So I want to lock that. And then I want to add in my value for C, which is this value in G. So I'm going to lock that G and the 4. And I'm going to get an answer of, you can just quickly change the color of the text. Apologies, there it is there. And it gives me a value of 83. This is old stuff. Delete that. So I'm then going to drag this down. And I get a whole lot of values. Okay. Now what's quite fun is I can go and I can insert my chart that I did in phase 1. And I create my little parabola. And I probably want to, as soon as you lock the axes, I'm going to do it from minus 20 to 20. I'm going to lock my x-axis from minus 15 to 15. Okay, great. So now I've got a sort of a little diagram here that is linked to my formula. So as I scroll, if I change the value of C here, I can start to see now that, you know, it's all starting to link together here. You can shift it down, and then start to play around with this, which is really quite a lot of fun. And then I'm going to create a little discriminant calculation. So I'll just do it on the side here. I don't have time to make it look good, but let's just do that. The discriminant will equal to D4 squared minus 4 times by A, which is B4, times by my C value, which is G4. And there we go. And suddenly now, when you start to get let's take a perfect square, they start to play around with it, they can see now, and hang on, the parabola touches at one point, the discriminant is 0, and they start to make all of these links between your roots, the nature of the roots, with something they've built themselves, which is really, really great. So you can also ask them questions. What happens now? Why is the discriminant negative? You know, how does that link to the picture? You know, if I suddenly turn this around now, and you can I mean, you can go on and on. I mean, you're maths teachers, but the concept here is quite important. Now, what is really quite fun for them now is that you say, well, that looks great, it works, but it looks horrendous. So they say, okay, well, let's get rid of this information. It must remain there. So if I just change the font color to white, the numbers are there, but you can't see them. Perhaps I don't want to see any of this. So I'm going to make the font white. I'm going to make the background white. I would like to make this look all sort of the same. I would like this maybe to be a little smaller, maybe just above the discriminant. I don't know what looks great. I don't know what's going to, and now you've got this little machine that's starting to look more and more like a little app that they think, yo, this is amazing. Simple concept. This kind of exercise, once they get going, this is when kids actually were really arriving early for class, and they really actually found it very hard to get them out, because once they got into their work, they never wanted to leave. They wanted to finish it. They wanted to finish it. And I think it was, I couldn't work out what it was, but I think it was maybe it was because it was their own creation. And I think there was a part of them that they could actually see the maths working in front of them, which was a very interesting kind of space to be in. So, I mean, you can do this with anything from grade 8 to grade 12, stats, Pythagoras. You can factorize trinomials. We could generate, using the quadratic formula, you could generate the two x values that this thing cuts at. It goes on and on and on. Okay, so that is my app development. Hopefully I've sparked something in you, and perhaps you can go back and try a bit later on tonight. But please don't be scared. Like I said, if you've got any questions, you're more than welcome to get hold of me or email me. And we'll take it from there. Right, so that's that. Okay, so then I've got a few other ideas and concepts, and please just look, I'm not going to go into details, but it's really to spark your thinking and really to encourage you to try things that are out of the box, because I think we spend a lot of our time doing the FOIL method and distributive law, and there's just so much more fun we can give our kids in this space. Okay, so I don't know why it doesn't want to change. Okay, a few moments and ideas. Okay, the first one, great fun, finding the center of gravity of the triangle, and you can explain it in theory, but you can have a lovely competition here. You get kids to make a triangle, find out where that center of gravity is, have a balance on a toothpick competition, actually make them build the stuff. And that's what I've really found where kids engage. Telling them that this is the center of a triangle is great, but when they actually go and what does that mean, and test it out and actually physically see, can this thing balance, or can it hang from a piece of cotton and remain flat? They love that kind of seeing it happen. So there's a little something to remember. And there's obviously a lot of maths involved there, your midpoints, construction work. The amount of maths that happens around that is also quite impressive. So keep that in mind. It shows if you've got design students, they start to take this on board. You can cut a piece of glass, find the center of gravity of a triangular piece of glass. Maybe they want to balance something on it. Yeah, so I really enjoyed that. Proportion, I took my grade 12s the other day to the center. Luckily, we've got some Lego there. And it's actually one of the first times I've explained it this way, because I think it is a section that kids struggle with, similarity and proportion often. And I put out 4 pink blocks, 2 yellow, 6 blue, and 3 gray. And I said, what happens if you take the 2 yellow and you divide it by the pink? What is the answer? Or if you take the pink and you divide it by the yellow, what are you getting? Are the ratios the same? Yes, sir. Yes, sir. Da, 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 da. Very easy. Then we get, I took the one, you take the yellow to pink and the gray to the blue, and then you put out a whole lot of yellow, a whole lot of red squares. And I said, well, what's out of place here? Like, how many orange squares do we need to make the ratios the same? And very quickly they come up with the 4, et cetera, et cetera. I then took and I put 2 lines together to start creating a triangle. So the same bits of thing. And I said, well, okay, let's join those 2 spaces there and join that. What do you notice about those 2 lines? Oh no, they must be parallel, sir, et cetera, et cetera. And I said, do you agree? You take the pink and you divide it by yellow, you're going to get the same as blue divided by gray. And they could actually see the split of the line, which was quite interesting. I mean, you can develop this further, but how many, then you leave out a few Lego blocks. How many are required here? And they will quickly work it out. So they start to break things up very quickly. So they start to understand what we sometimes just tell them. These are parallel lines. It cuts the lines into 2 parts. And anyway, this really worked. It was a visual way of doing it. They enjoyed just playing around with the Lego and seeing it visually. So don't be scared of using blocks, cutting things up. You can do this with squares. You could definitely find different ways of manipulating this. Domain and range, I've always found is an interesting one. And the one day I saw kids cropping their photos on their phone, going like this and like that. And I thought, hang on, that's domain, isn't it? And there's your range. And I started explaining it like that. I'd take a picture and I'd say, well, hang on, I want to see this picture of the Springboks. I only want to see it from -3 to 7. So I'm going to cut that part off, and I'm going to cut that part off over there. And then I only want to see the picture from -8 to 1. And I've now explained domain and range in a language that they understood very, very quickly. It wasn't something that was foreign to them. And then I could take a parabola, I could put any picture on the screen, and they really, really found that very useful. My favorite one, Snakes and Ladders, the best board game of all time. I tried this out once, and I think this is something I always use, but to introduce probability, we often go straight to sort of flicking coins, but I found this was so much more engaging. I had a Snakes and Ladders competition, knockout, and we had a person who won and a person who came 16th or whatever it was. And then I started to ask a few questions, if you're using 1 dice, what's the minimum number of moves you can take to finish the Snakes and Ladders? What's the quickest way to finish? And after playing the game for a few times, I'd say, oh man, you have to throw a 3, because then you go up the ladder to the 16. I'll just show it there. Then from 16, you have to throw a 5, and you go up the ladder to 32, and then you finish with a 4. And then you say, okay, that's great. What's the probability of that actually happening? And they quickly said, yeah, that's sort of 1/6 times 1/6 times 1/6. And you move on. A great way of sort of introducing it. And then I said, okay, if you play the same game, now I've got 2 dice. Always get a die or dice. What is the probability of completing the board in 3 turns? And that suddenly became a little bit more interesting for them now, because you throw a double 6, you think, well, that'll take me to 12. I hit the snake, I'm going to drop back to 2. That's not going to work. So you go back to what is the quickest way that we worked with 1 dice, was to throw a 3, then a 5, and then a 4. And it started to introduce you to this table. Just by the way, there's one typo in this table here. This should be a 3 over here, just for interest's sake, but we can change that later. And suddenly they got the 3, the 4, the 5, and then they started to say, well, sir, you can actually throw a 4, then an 11, and then another 11, and you'd also finish in 3 moves. And then suddenly to find all the different combinations to use 2 die with to finish becomes a real challenge. And then you can ask them, well, what is the probability of that actually happening? And that's a great question for them to work with. So a simple Snakes and Ladders board, lots of fun. They come and play. There's a winner. There's a lot of maths happening behind the scenes they don't even know about. And you can ask some really good questions. If your class is really sharp, you can change the Snakes and Ladders board. And really what the beauty of it is that you can take a simple exercise and adapt it to whatever you're working with. So, you could start this in grade 8, you can take it to matric, you can get some really good probability questions here. And I've always hoped that from this, when they play a board game or they start thinking about games, they start to realize actually that all of these things have probability built into them. And what is it about? So that might spark something. So find a board game at home and think about it a bit. I'm sure you can develop a really good question there, or exercise, or lesson. Mini maths tours, always great. At school, there's always a place to go on maths tour. The netball court is where you can find lots of area and perimeter type questions. And you can ask the simple question, like if you were the Proteas coach, what type of mathematics would you apply here? And they say, well, no, I'd work out the area of the circle, and I said, where must your fittest player be? And simple questions like that. It doesn't have to be like used in that world, but they start to see that maths can be used in a sporting space to make you a better coach, or you can be a team analyst, whatever it is. They see that kind of link. My classic one is always that's the netball circle. The red person's the attacker and the blue's the defender. Who's running further? And they kind of work it out, and then you can say, well, who needs to be faster? Do you need does your defender need to be as fast as the attacker, etc., etc. So you can start asking these kind of questions. You don't even need to know the answers yourself. It's just, it gets them thinking. They have to work out a little bit of perimeter, a bit of circumference. They have to think about that type of space. And the thinking behind it is really what I try and encourage. You don't have to do this every lesson. It's once in a while. It's something that always remember. There we go. If you were the goalkeeper coach for a hockey team and the striker is striking it from this point here, what would you suggest to the goalkeeper? Do you stand on your line, or do you move forward? What would be best? What are you achieving by moving forward? Are you cutting the angle down? What are you actually doing? So that type of thinking is quite fun for them. So I've seen a lot of that's really a really great lesson, and you can create a simple worksheet. Like if you were the Proteas coach, or if you're the goalkeeper coach, what would you suggest? Find a mathematical thing that you think would make them a better team. This is also a great one over here. We're lucky enough to have a fountain. And I literally took a class and I said, how long would it take this hose pipe to fill the fountain? I put them in groups of 3, and they arrived early and they left probably about half an hour late. They absolutely love this. They worked out that there's a rectangle here. There's a couple of semicircles. They said, sir, do I need to fill up the sort of middle part there? I said, of course you do. And in the water they're measuring the radius. This is a grade 9 class. And then they said, well, sir, how do you know what the rate of the water is coming out of the hose pipe? So I said, I don't know. What do you think? And then the discussion starts to happen. Okay, let's get a 5-liter bottle. Let's fill it up. Let's time it. Let's see how long it takes to fill up that 5-liter. Okay, that's 5 liters per 30 seconds. They convert it. They apply that to their calculation, and suddenly you've got a really engaging, fun lesson on volume, area, rate of flow, and you can really talk about things there. So don't be scared to find places like that. The good old long jump pit, I found that. Just to go and do Pythagoras drawings, just because you drew in the beach sand, I thought it'd be quite fun to take them and draw a few Pythagoras questions there. Didn't add any value except that it had a memory. They went there, they thought they were Pythagoras. So it was quite fun. Try different things like that. Much better than doing a worksheet. Formula 1, that's my grade 12 explanation of the point of inflection. I say, as you're coming through that chicane, where is that? Look at this, look at the wheels, the wheels are facing that way, then it's facing that way. Where is that point of inflection? What happens to the steering wheel? And they absolutely get that very quickly. And on that, I mean, it's still something, this is actually a bit of work on, I'll be honest with you, but I think there's a lot with Formula 1 and this concept of point of inflection, tire usage. And if you go, this for me is a great research project for a kid. One of your top kids, go and link what do those team analysts do? How does maths come into it? What are they thinking about? And you'll find someone in your class who will take this to the next level, I'm sure. Not everyone, but quite a few. Oh yeah, and it is time for coffee and a donut. It is getting to the end of the afternoon, but I'm going to explain this, what I mean by this, and then it's not a must, but it's sometimes with classes, you have to find different ways of explaining concepts. And I found that I got a grade 9 class. They couldn't understand that you only have to prove 2 angles in a triangle to make them similar. So I said, okay, you got 2 different wallets. Someone's got a pink wallet, someone's got a black wallet. They've both got 180 Rand in it. Both people go and buy a coffee and they buy a donut. And I say, how much money is left in the wallet? And they say, oh, yeah, sir, it's 115 Rand. 115. Okay, so I say, great. So it doesn't matter what the wallet looks like, but there's 115 Rand left in it. And then I would take that to, say, the triangles. And I would say, okay, well, in the yellow triangle, you've bought a coffee, you've bought a donut. What are the angles of it? What do the angles of a triangle add up to? It's 180. So if I've used up 2, what does the third one have to be? And you talk about that leftover space, and they get it, and it's often, I think as math educators, we sometimes forget that these concepts are simple for us, but sometimes not tangible for the kids. And I really, it's quite fun to find different ways of explaining these type of simple concepts. I think that's it from me. So really my presentation is really just to spark your thinking, to encourage you to get out there and try something different. Don't be scared of it not working out, because it won't sometimes, but it often does. And you'll be surprised about the lessons that are learned along the way by you and the kids. So go for it. And I always say, I often sit back sometimes, Tristan, I'm sure you'll agree with me, that when you're a first year teacher, you try some crazy things. And after a while, I think time and stuff wears you down in terms of your creativity. And I often think I must always go back to those moments. We mustn't forget to be a little bit crazy sometimes. So that's it from me. I hope you've learned 1 or 2 things, you've thought about a few things, and yeah, any questions pretty much, I suppose.
Yeah, so thank you so much for sharing. There's been some great feedback in the chat. I've relayed a little bit of it, but yeah, Rowan saying, I wish I had this when I did maths. Shahida is saying motivated to try this myself. That was after the app. Yeah, Anthony's thanking you for these absolutely wonderful ideas. As well, Amanda, thanking you as well. But yeah, I mean, I was just making notes as I was going through it. Because what I think, and we discussed it, and it kind of relates back to actually a presentation that Paul DeVette did of teaching maths low tech or high tech. And what I loved about what you did with Excel here was I felt like it was like teaching maths mid tech, because the problem with these super advanced applications like well, GeoGebra even, that's a very well coded application. The UX is quite intuitive and easy to do. Is that when it's quite easy to engage with because they've got the user experience so finessed, you miss some of the fundamentals. Whereas with building it from Excel from the ground up, you know, if you're gonna make a mistake, you're gonna make the mistake, and you're gonna have to solve it at every point. And so you're really teaching those fundamentals, and at every point it was linking back to key concepts. I mean, when you put all the coordinates down, you started with the coordinates, then you cropped the axes to give domain and range, and started talking about relative referencing when you drag down, offset because the scroller only went to 0, it couldn't go below 0. Transformations, when you started tweaking the A, B, and C parameter, and we could see the parabola moving, and the learners have actually built it, so it gives them that real sense for what is going on, where, as you say, when we just tell them what it is, they don't really deeply understand it. So I really appreciate how you've gone through it fundamentally, step by step, because oftentimes we go through these things too quickly and we miss windows of learning with our learners. And the more experienced we get, I think the more we have to remind ourselves to slow down and remember what leaps our learners are going through that we might have gone through 10 times already, but they're going through it for the first time.
100%. I think it does slow them down. And like you said, it's all those little problems along the way that are just I think are so important for kids to experience. Just it just slows them down. They think about it. It's something that they will sort of put in the memory bank. And like you said, I think, you know, judgment, it's very good, but I don't think every kid really engages with it if we tell them to go and move the parabola around and see what happens. They haven't, it's not theirs. The sense of ownership is quite a powerful thing, actually. And I think that, you know, I'll tell kids, this must be emailed to me, finished by tomorrow, and emailed to me by, it must be in my inbox by 12 o'clock, your app. And all of them are there. They're very proud of what they produce. And even if they go back and they're asking a mate to help them, it's still part of the process. They're still actually really engaging with the work. So that's always makes me happy. Yeah.
Absolutely. We've got some messages in the chat that I just want to relay. Esther, this is very innovative. I appreciate your creative ideas. It certainly makes maths interesting. And Shahida, thank you, Simon. This does help in making maths fun and linking it to our everyday life, and also stimulates the cognitive process of every child. Exactly. I love that it highlights seeing the maths in the everyday, because then you're thinking about it all the time. And you're seeing the connections, you're making the connections, which is embedding the understanding of what you're dealing with in X's and Y's and functions and all of that. And it comes back to being able to visualize mathematics. We've always said, if you can see maths, you can do maths. If you can see it graphically, if you can see it in action, it's so much easier to understand it than just numbers and variables on the page.
Yeah, thank you.
All right. Thank you so much, Simon. Appreciate it. Great. So we are now going to move on to the second part of our webinar this afternoon. So we were fortunate to get some knowledge share from Simon on how we can really bring our classrooms to life and kind of shake us a little bit to not get stuck in a rut and try things in the classroom. But we've also been receiving a lot of requests from our Neo Series partner schools to have a little bit of FaceTime with Trish, to pick her brain about her experience in leading maths departments, and also to pick her brain relative to the Neo series and the best ways to implement the Neo series in your schools. So that's what we are moving into right now. I was just going to say something else, and then it left my mind. All right, so let's get into it now. I see many educators from our partner schools. Thank you so much for joining us. We appreciate having you on. So many of you will know Trish, and that was the thing that I wanted to say. We thought it would be quite nice to bring Trish on together on this webinar, because it turns out that Simon was once a student in Trish's classes, and so we thought it would be quite a nice dynamic to get his insights and Trish's insights across multiple generations. But Trish is really going to lead the second half of the session, and Simon will chime in on any elements that he feels compelled to share on. Most of you know Trish, but some of you, for the younger educators in the room, I just do want to give a bit of an introduction. Trish is a seasoned educator with extensive experience in teaching and curriculum development. She's led the maths education team at Advantage Learn for over a decade, specializing in MBT preparation, further studies maths, and the Neo series maths content development. And before that, she was head of department at some of the most prestigious schools in the country, Kearsley College and Thomas More College being a few of them. She co-founded Advantage Learn, and she spearheaded the development of the Neo series. And so it's a great opportunity this afternoon for us to pick her brain and ask her questions about some of the challenges that we're having in our classrooms, or potentially with the Neo series, or some opportunities that you're seeing. So with that, I want to open the floor to you all to ask away. We're here to answer your questions and here to see if we can assist in any challenges that you might be having. All right, so if you do have anything to ask, please pop your hand up, post your question in the chat or in the Q&A. If you pop your hand up, I'll open your voice channel and we can take it from there. Otherwise, I am watching the chat and the Q&A. But maybe to kick us off and to get the conversation going, I think the first thing, possibly the first thing to ask is, Trish, is how did you go about successfully leading departments to get the maths results to the heights that you achieved at schools like Thomas More and Kearsley?
Okay, so, it's weird not seeing any of you, I must admit. So I think I was really given the opportunity, which I didn't expect and wasn't something that I was looking for. In fact, I was very happy just teaching maths, but certainly I'm very competitive. And so therefore, when they set the challenge for me, I thought, well, here I go. And so I think I'm going to talk mainly about the fact of going across to Kearsley, because at Thomas More, it evolved that I became the head of maths, but I found that quite daunting to move into a school where I haven't taught and to be placed as head of maths in a school, and where their expectation was, the first thing is that they said to me, we want maths excellence. And I found that quite, well, when I heard that, I went, yo, here we go. And I knew that I had to start at the bottom. And so when I arrived at Kearsley, it wasn't a matter of my going and teaching the top classes by any means. I felt that I would have to see what's happening at the bottom, which is the grade 8 and 9. And in my first year of teaching, I taught all 5 grades as head of maths. And it was to feel what is happening within all the grades, what was the system. And then having had that year, I was able to start to see a strategy going forward. And it was pretty simple in the sense that I always, as head of maths, took the bottom set, grade 8s. And then I always took 4 sets. So I was only missing 1 grade. And I think that helped a lot, is that I was in all of the grades excepting 1, which I was sad about. And that mainly became the grade 9, unfortunately, which I think is it's a very, very important year. If I'd had my choice, I would have done both grade 8 and grade 9. I think that's something that is sometimes overlooked is that it's no good trying to, and I think a lot of you know that, it's no good trying to start at grade 10 to improve the maths. It's got to be at your grade 8 level. And I think that was my main strategy, is what to do with at grade 8, at the grade 8 level. And I think that what I did was I thought, what do I want at a school like this? I would like most kids to take maths. That's what I want. If you're paying that amount of money, what do you want? You want them to come out with maths. And they said maths excellence. So where is the best place to do it? And I went to grade 8. And so I was ruthless. I then cut out anything that I felt was not really going to take these kids to being able to do maths. So I narrowed it down, and I made the syllabus narrow, because you can do that. And I then concentrated on certain topics that I knew that will enable more of them to continue with maths. So the topics that I really, really concentrated on was, for instance, all the algebra in grade 8, and the fact that equations, I mean, to me, as I said to Chris today, I said, if there's one thing that I would want a grade 8 to be able to do, is to be able to do an equation without even having to be reminded. They must get to the end of grade 8 and they must know how to do it. That's it. So that when they get to the next year, it's not something that I'm going to have to teach again. And then I said the other thing is obviously the geometry, because as we know, and you saw today, you know, even the proportional theorem, the trigonometry, all of that is the geometry is key. And so I think I spent, and I didn't mind about the length of time that I spent, because nobody was putting any constraints on me. And I would spend like 6 weeks in grade 8 on geometry, not even blink. But as long as I got all of them to come out of there having an idea of what the geometry is all about. And then the other thing was, I think those were the main things. So I know, you know, a lot of people say, well, what about measurement? What about this? What about that? But I often thought that as they get more and more confident, they didn't like measurement. They don't like it from primary school. You get that feeling immediately, no, I don't like it. And so, you know, the thing is, why go on to something that they don't like? And sometimes as they get older and more mature with their mathematical thinking, they suddenly find it. Oh, it's not so bad. Oh, they understand. So sometimes we teach things to the kids where they're not mature enough to take it. And I think that's something that we don't think about. Are they mature enough to do that? And then we lose them by that way. So that's really what I did. And I think the other thing that was key is the fact that all my tests were cumulative. So often people think, how could you have done that, Trish? What you were doing sequences, and then at the end of sequences, they didn't get a sequence test. They got a cumulative test, but within there were sequences. And the reason why that started to really pay off is that they would have an equation in there. And then it started to really sink in, and they started to memorize it. Whereas if we're only doing it on one section, that then just gets put to one side in their minds. And then that's why we have an all fall down in exams. So they do well in tests, and I'm sure you've all experienced that from parents. They were doing well in their tests, and now they come to the exam and they fall down. And that's what I heard from parents. And I knew the only way I was going to get around this was to do cumulative testing, which is quite difficult. But if they told in advance what's in the test, and if they have some resources in order to prepare for it, then you will not believe how much easier it becomes with teaching these kids, because they know how to do an equation before you've even started doing graphs or something like that. You're not having to go back over an equation before you start graph, therefore minimizing the time that you're now spending on graphs. So for instance, then having the time to be able to go and make an app, you know what I mean, because you've spent quality time on the things that are really, really important to enable you to solve problems. That was what I did. So like people would love to ask me, did you do word sums? No. But why not, Trish? Because they're not mature enough. We mature, the teachers can do it because we've got all the skills. We've got every single skill. So then the little ones come along and they're terrified of it because they just don't have the maturity. So I left it and I only did it in matric, and the kids got it. They got it straight away. They didn't even have a problem. They were able to do it. And I feel that, there's lots of things in maths it's all about mathematical maturity in my thing. But I think I've said enough. I'd love to hear questions about, but so then to go back to the NEO series, let me link it all up. So the way that I taught at schools is, and if Paul's still here, I don't know, but he will say that I'm hugely energetic. And I think that that's what I did in the classroom successfully. And some of my teachers took it on, is that every day I would walk in and I would do a question on what I'd done yesterday. And it would be on the board like that. And they'd sit dead quiet and they'd do it. And then again, it's this whole reinforcement, continual reinforcement, instead of putting things aside and then suddenly giving them a test on it and expecting them to be able to see in depth. And they can't remember it all. They don't have the time, especially in our schools. And I never want to take any of the way we do things in South Africa with a holistic education. I think it's absolutely awesome. And so I just feel that I was assisting them in being able to cope with everything that they have on their plate and more. And I was happy they were doing that as long as I was supporting them in the way that I presented my lessons. And so to go back to the NEO series, why is it so bitty? Why is your NEO series in small bites, Trish? Because first of all, and I'm sure you all know, they can't concentrate for that long, all right? Secondly, when I teach, I don't get them to copy off the board. I want them to get to hear me and to listen and to understand. And so I would do one sum, that's it. And then I would rub it off the board. So they weren't allowed to copy it down. They had to listen. They had to concentrate. And I did that all the way through all my grades. They weren't allowed to copy it down. I then put up a sum on the board, but then I walked. And the reason why I walked is to keep fit. And also, the fact is I looked at their work. And what the kids said about that is I was showing interest in their work. But I never, ever bent down to one particular child. Because what I found is if you do that, the others somehow lose, they start to misbehave, they feel you're only interested in that person, they start to do also. So it was never like that, but I am lucky. I would look down and I would just, shake my head when the kid looked up at me, and then I'd carry on walking and I'd carry on and I'd go to the board by having walked all the way around and I'd say, okay, kids, and I'd draw a conclusion. I don't think you quite understood me. And you see, then they get a feeling that you are interested in what is happening to them. It's not you just going through one sum after another. And it's weird. You think, oh, this must take so long, that you then walk to see, what is happening with all of them? Have they understood you? Because they might be too scared to say, no, I don't understand you, man. Whereas you've taken all of that fear away by just looking at their work and walking up to the front. The other thing, like it happened to me last night, is I was teaching further studies maths, and I was teaching a concept of limits to infinity, at infinity, sorry. And this group has started to really do well in maths, and that's what you would really like to see them starting to really do well. And instead of, and it's something that you as a teacher have to take it on and really think about, as Simon says, think about how you can help those particular kids in their problems. And it's not necessarily, that makes it more difficult for you, because you can't just simply go and I'm going to just do this exercise. You've got to be selective and all of that. But what I'm just saying about it is, I digress, but the thing is, like, I saw two kids do the sum. So I said, all right, try it. I didn't even show them. I said, there's the method. I'm not showing you. You read the method. Okay, I'm going to give you a chance because you're doing well. I think you can teach yourselves. And I walked and I walked. And then I was pleasantly surprised. And I went to the board and I said, okay, I saw two kids get it right. I'm going to show you what they did. And it wasn't my way. It was the kids' way. So therefore, they really listened. I said, and I didn't say names. I don't name anybody ever, never. So, and then I also show where kids go wrong. So anyway, so my NEO series, going back to it, is why it's small is that, and you'll see how we do it, is we do a worked example, but I just do the worked example and then I give them one to try. But then we've got a guided exercise. And the reason why we use the guided word is that's exactly what I did. I was guiding them, but I was full time into guiding them. I wasn't going and sitting down. I was going and I was trying to keep them going. I'd say, all right, try number 1. And there was no answer there. They would try it. And then I'd walk. And then I'd see, oh, now you're getting it, kids. Well, now go and do 2, 3. And then I'd give immediate reinforcement. Oh, you both all got it right. Okay, well, now you can finish the exercise. Instead of them, and then they felt that they could do the exercise. So you wouldn't get the chatter. It would stop all the chatter. Then you get to the end of it. It's not too much to not grasp. And then I'd go, okay, now we're going to teach a new concept. And so therefore, then the practice exercise they could go home and do. And it's not huge. It's not a big lot, so that they feel, oh, it's, they're not going to be able to finish. Interestingly enough, the kids like to be able to finish something. We don't think about that. So in other words, you give them 5 out of an exercise. They haven't finished that exercise. How do you know that you didn't lose? They think, well, what if I didn't do that one and was hard? And I get one like that in the test, but I didn't have it given to me in homework. So it's better to have something smaller, attainable, that in fact the next day you can actually go through it and you can say, well, which ones didn't you get? But that's where we come from, and that's how the NEO series is going. And we do have a unit revision at the end of each one, which isn't. I haven't tried to make it particularly hard and to make them have all the challenges in there. A unit revision is literally to see, am I able to have I got the whole unit and being able to apply everything you've done in like a test situation. In other words, in a unit, in one unit, the end of the lesson. And so that's why we've got that. And then the other thing that we've added this year is the fact that we've put this, Chris, I need your help, is the
topic revision.
The topic revision.
Next topic revision or the question bank?
The question bank, that's it.
Okay.
The question bank is, we've introduced the question bank, and I'm hoping that's going to be hugely helpful to our partner schools, in that they've got a source of questions that they can go and use, and then and therefore set tests from or whatever. But I think I've said enough.
Oh, that's great, TP. I think I'd like to hand over to Simon in a moment to embellish on anything he feels you'd like to highlight or talk to. But we've really tried to distill Trisha's experience in how she's approached maths at her departments into the structure of the NEO series, because she was so successful in leading departments and helping learners to achieve their potential in mathematics. And so you'll see it in the theory block, the method block, the worked example block, which is intended for the educator to show the learners how to do something. I do, and then we have I think I said worked examples there. That's included in that block. I show you how to do it. Guided exercises, you do, we do it together, and I help you over the hurdles that you encounter while you are trying to do it. And then you do in the practice exercise, and then the unit revisions that can be used elsewhere. And Trisha's geared the syllabus. She's stayed true to the CAPS formulation, but like she said, there's some areas that should be emphasized in the lower grades and do lead to greater success in the other grades. So she was quite liberal in her approach to following CAPS and not sticking that black and white to the curriculum, because in her experience she understood that certain topics had an inordinate effect on mathematical learning higher up. And so in the lower grades, if I understand you correctly, TP, it was algebra, geometry, and functions. And those are the ones to focus on. And the smaller topics were de-emphasized because they weren't that foundational. in that regard. Now, in saying that, I do understand that it's easy for someone with Trisha's experience to say, you know, don't worry about the syllabus. But if you're a young educator, you don't have that sense for the syllabus, and so it's quite difficult in that regard. And I think maybe that's a good way to move the conversation is, how do we support young educators who haven't generated that amount of experience to know what they should emphasize and what they should de-emphasize? Do you have any thoughts on that?
I would think it comes from the lead, the head of the maths department, how they're going to help the younger ones. I think that, like, for instance, is that I, taught in the lower grades. So I was with them, and I was making worksheets so that they could see how I did it. And they were using them. And so it then helped them. I think I carried on and did the worksheets for the grade 9s, the grade 10s, the grade 11s, the grade 12s, in order to support all the staff, because the thing is, a lot of the staff have got so much on their plates. In other words, they're doing sport or they're doing a debating and all of that. So as a head, especially with the young staff, I would be supporting them tremendously, as I do in further studies maths, is that, and helping them and guiding them by them seeing what I give to my students. And then they also then should ask, or I'd rather go and ask them, how are you doing? What's it like? How's your class? And all of that. So that's the way that I would do it.
Any memories from your side, Simon, when sitting in Trisha's class?
No, I've made a few notes. I mean, I agree with Trish on a number of things. I mean, if you had a step counter back in my day, I think you would have done 10,000 steps by the first 10 minutes of the lesson. I mean, you're always around the classroom. And I think it's a very powerful thing that, like you say, just glancing your eyes at kids working, and I do the same still, actually, myself. I don't think I do as many steps as you, but I really liked a couple of things. I think your reference to algebra, those skills just being so important. The number of kids that I see who get to that moment where they have to find the x-intercepts, but it's a basic equation and they just don't know, they can't link it or do it. You're kind of setting yourself for failure if you can't get that at a young age. So fully agree with you. Functions, very, very big section that I think the more we can drill that link between the x and y, also a very big section. And like you said, geometry, if then statements, it actually all goes back to the app development in a way, but that way of thinking is so critical. I also, I loved your thing about your examples that you give, like you talk about these exercises. I find, and obviously it depends on what level of class you're teaching, but I don't give 20 examples for them to do at home. They're just, like you said, they're not going to finish them. But you know that because of your experience, you will know what 5 questions that the 5 key questions that they need to do, make sure they've got those. And you almost know where the mistake is going to be. I mean, that's where you get to nowadays. But I think smaller worksheets for homework that you say they can actually finish. And like you said, come back and actually, when you go through them in detail, because I think that's lost. I think I see often we don't get to things because there's just too much. You don't have the time. Even things like, this is Trisha, I would like your comment on this actually. I love that. I love your idea of that cumulative test. I mean, I just, that is a brilliant idea. And I look at kids in my class who are great in those little silos, but you get to an exam, it's all fall down because they can't link, they forget there's other maths. So I think that's a really good idea. But I'm also interested in your comment on, and maybe there's other teachers out there who've got a comment on things like, I don't know if it's links to neuroseries, but tests. We doing your corrections for tests. What does that look like? A test for me is a point in time. It's just really an indicator. For me, I tell my kids the importance of a test is not the test, it's what happens afterwards. Do you go back and actually correct yourself? Do you learn from the mistakes you made? Do we need to start forcing our kids to rewrite that same cumulative test until they're getting a certain percentage? These are the things that I think we often don't do. We sort of go through a test, we hand it back. A kid who gets 40% generally takes the test, scrunches it up, chucks in his satchel, and goes home and never looks at it again. And there's no learning that takes place there. That cumulative test is a really good idea, and I love that idea of fewer questions that are tailored that the kids can finish. I think that's
Yeah, I know TP does have quite a specific approach on testing. If I'm not mistaken, TP, it's kids get the memo as soon as they step out of the assessment.
Well remembered. As soon as they stepped out. Yeah, well
as soon as they step out,
yeah.
because that's the window of learning.
Yes.
They've just been struggling on the question, and now for us, them to only get the memo a week later, they have to embed themselves in the problem, and most learners are not going to do that. But as they step out of the test, to have that memo and be able to discuss, oh, that's how you do it, oh, that's where I was stuck, then I remember that from my school days and being in the Thomas More classroom, that was really, really helpful. But it takes a hell of a lot of effort and planning and organization on the maths department's front, because you have to have it all ready, you have to have it all set up and all of that.
No, I mean, I've even taken kids and given them the same tests, write it, mark it, go through the memo with them, bring them back the next day, rewrite the same test, mark it. And you notice the mark doesn't actually change that initial test that much, even though you've got gone over it. It's incremental, but there's a point where maybe the third time, maybe the fourth time they write that same test, then they finally put it all together. It's an interesting observation that I've made, and I always wonder, how many times you have to rewrite a test until you always get 100% for it. And I know it sounds pretty draconian, but I think there's a lot of by even just because you can never really learn a memo. Let's be honest. You have to still understand the steps that are taking place. Anyway.
Yeah.
Because from the last test, they might have got that thing wrong. Do you know what I mean? And if if you're really organized about and taking, well, I noticed that they all got only 8 out of 20. If the general average on that question was that. Do you know what I mean? And then you can somehow not let them know. But I also did. Before, when I still do it, before every single test, they got what you need to know. So they were given how many marks it was, how long it is, what the content of the test was, which was cumulative. So because they forget what they've done, they've forgotten that they had to learn factorizing and all of that. And in fact, I went to so much trouble, I would actually put the mark allocation on factorizing. You have 10 marks. On products, you have 5 marks. So in other words, you then are helping them to learn to gauge where they must emphasize to gain better marks. And they I must admit, I really think that was the major thing that really turned it around, is the fact because they didn't forget anything. And that's why the syllabus that I chose was, where do you start at the beginning of the year with a grade? What do you want at the end for these kids out of that? Do you know what I mean? And it's an easy thing, because it's a weird thing. You'd say, so what would you have started with in grade 11, Trish? Straight away, I did quadratic equations, and I went straight on to functions. Straight on, because it's the beginning of the year. They're keen. Do you know what I mean? They would like to learn something new. Do you know what I mean? It's a new start. You're giving them a brand new start. And so, it's those sort of little things that I thought about, that it's start to the year. So the same thing happens in every single grade. They've just got all their results. They've had a fabulous holiday, and mom and dad have said, now you're going to really try this year. And so then you start the beginning with almost like the harder stuff, because they are fresh. They are wide awake. They aren't that tired. Do you know what I mean? They haven't got into all the sport. And those were the sort of things what I thought about when setting up my curriculum. And that was what was fabulous, was the freedom to be able to strategize as to how are we going to get the best out of these kids, in this all-important subject, unfortunately. Do you know what I mean? And the time constraints of trying to get through everything. So that's why I maintain that was the win, was the cumulative testing.
Yeah, absolutely. And it was, so we embedded the cumulative testing in the Neo series via the mixed topic revisions as cumulative revision exercises. And then we had a challenge developmentally in the Neo series, because many schools actually got back to us saying, listen, we love the content, but we're not covering it in the order that it is in the Neo series book. We're covering it in a different order. And therefore, the mixed topic revisions are not actually applicable because they've been geared around the Neo series ordering. And so we made some adjustments to accommodate different kind of cases. We recommend that you cover it in the order of the Neo series because Trish has thought deeply about what topics should go first and what follows nicely on from that. But for those of you that don't follow the Neo series ordering to the T, what we've done is we've taken the mixed topic revisions and we've aggregated it into the back of the textbooks by section so that you have pools of questions per section that you can deploy as you need to. But there's also guidance around which questions you should deploy when, if you are following the Neo series curriculum. So we found developmentally we've been stuck between a rock and a hard place, kind of, because there's some use cases of the one and other use cases of the other, and it's given rise to our question bank, which we launched this year, and to the educators in the room. I know that there's a high percentage of educators that don't even know about our question bank. So I'm encouraging you, please go to the Neo series Educator Library. Our development team has been working exceptionally hard on building out a large question bank with full work memos for you to go in by topic and pick and choose questions that you can use in your revision sheets, that you can use in your tests. And we hope that helps you. But interestingly, we've also got feedback off of those question banks to ask us, but actually, we would still like the revision sheets and exemplar tests that follow the Neo series curriculum on a termly basis, because that's also useful. So we've recognized the two cases, and we're now building for both in the Neo series educator libraries. So there will be resources that directly align to the order of the Neo series, and then there will be question banks for schools that are covering it in a slightly different order for their own reasons, and so that they can still deploy the resources in a helpful way. I just want to relay some of the sentiments from the chat. Sarika, thanks so much for joining us. Says, we're using the Neo series for our grade 8s, and they're currently at a much higher level of standard than our grade 9s. We absolutely love the Neo series. Thank you so much. Thank you, Sarika. We really appreciate the sentiments and the feedback. Our education team works tirelessly on these resources, and it's a real thrill for us to get that positive feedback. So I'm glad it's helping you at Cornwall. And then Celeste was just reiterating, that is the biggest problem in our government schools. Our syllabi are packed through high school, and the district advisors will never let teachers or HODs choose the most significant topics. It is expected that everything is done in the senior phase level. It is so much of a rush from January to November. Yeah, so, and that's another thing that we believe in our development of the resource, is that the Neo series resource is that not only should the resource evolve as we get feedback from our schools and we understand what's working and what's not working, but the curriculum should be evolving as well. The CAPS curriculum is a very well formulated, structured curriculum. Like it's a good, clear document, but it makes sense that over time, potentially the weightings can change, potentially some sections could be removed from certain grades, but it is a context that we work in, and so we need to figure out how to creatively work around that curriculum statement, because it's not necessarily going to change quickly. There's massive change management that they would need to undertake if they did change it. So I understand why the department wouldn't want to change it, but I think the conundrum is, how do schools operate when they're required to follow the curriculum, but it's not necessarily optimal to do so. And I suppose my sentiments on it are, at the end of the day, you're working towards an exit level assessment. So there's the assessment at the end of grade 9, the ANAs, there's the assessment at the end of the grade 12s, the national senior certificates. As long as you cover all of the content before that exit level assessment, well, you've done justice to the curriculum. And that would give me peace in terms of coloring outside of the lines of the curriculum to some extent, because I do think that government schools versus independent schools are held to a bit of a different standard in that regard, and monitored to a different standard in that regard. And so it is a challenge for educators to manage. I don't know if there are any thoughts on that that conundrum, Simon.
Yeah, I think it's a conundrum we all face, this time thing. But I think, like just said, if you've got it's important to cover everything, but maybe your development of your department is really around focusing more time on certain specific topics, possibly. Maybe if you're going to do extra sessions or you're going to give extra worksheets, they revolve around those topics that Trish has spoken about. Maybe focusing in on those as dedicating more time, because that often leads into the other topics, and it opens those up because you are more skilled at the other one. So it's really around finding which topic is going to actually is key to unlocking the other ones, and I think that's the challenge. I mean, I totally agree. I mean, I think we are in all schools, we pack things in, and you're kind of going from A to B to C. You're trying to tick everything off the list, but that importance of understanding certain key topics, like I said, is very is critical really to the success, I think, of the others. So that's how I would play it. I would look at finding ways of giving extra in those areas.
Yeah, that's a helpful steer. Yeah, so getting the coverage right, but where there's additional time for additional revision or additional revision resources, weighting it according to those critical areas.
100%.
Brilliant. Okay. Yeah, so I had a bunch of other questions prepped, but we've kind of covered a lot of the concepts there. If there are any other questions from the forum here this afternoon, please send them via the chat, pop up your hand, or put them in the Q&A. I am watching that forum. There has been one thing that has come through quite strongly from our partner schools, which I would like to address. One, two things. We've spoken about the question bank, which you'll find on the Neo Series Educator Library. Another two technical questions that I'd just like to address. Why are the textbooks so large? TP, can you maybe just address that one?
Well, as we're saying, that they are quite large sections of work, and I think it's also because we're doing it in smaller bite sizes. So, for instance, let's just take an example of like I want to teach the kids to do adjacent angles on a straight line. So then what happens is I will go and do that topic, and I will do it so that they can also include in that the equations with angles on a straight line, adjacent angles on a straight line. So they have equations in there. So that takes up quite a lot of space for drawing the diagrams. Do you know what I mean? And then having the amount of questions that are going to make it worthwhile, in a sense. I still don't feel there is, but then what happens is you then move on to, say, for instance, doing vertically opposite. But then I do vertically opposite on its own initially, so that they get the concept completely without any other interference. But then I've got to put it together with adjacent angles on a straight line. So then I've got to get an exercise which has the two incorporated. Then you go and you teach another topic, for instance, alternate angles, and then you've got to put all three together. And so it just builds like that. Do you know what I mean? And so that's why the textbook is big. And so it's the fact that I'm not teaching a lot of concepts at one time. So in other words, so therefore it sinks in. Do you know what I mean? They're not seeing one example of this kind, then they go to the next example and they see another kind, but it's still related, but it's sort of different. It's more difficult. Do you know what I mean? And so therefore they don't consolidate the easier ones. I know people will say, no, your textbooks are hard, Trish, but it's that sort of thing that makes it so big. That's what the problem is.
Yeah, but we have recognized the size. I think we've got it right in grade 8 to 9. In the upper grades, grade 10 to 12. So just to remember, our model in the Neo series is that our textbooks are available as textbooks and what we call write-on textbooks, which is essentially a amalgamation of a textbook and a workbook, like a write-on exam. So space is given in the textbook for learners to write in the textbook. So it keeps all their their work together. At grade 8 and 9 in the senior phase level, the write-on textbooks are a nice, manageable size. But when you get to grade 10 to 12, the syllabus is just so large that the write-on textbook model actually doesn't work. It's going to be an 800-page doorstop of a document. So at grade 10 to 12, the print copies of the textbooks are available, or will be available depending on what grade, because 11 and 12 are currently in final production. The print will be available as textbooks. The write-on textbooks in grade 10 to 12 are available digitally for tablet-enabled schools. Like, it's very useful for tablet schools that are using tablets quite extensively to have access to the write-ons. But at a grade 8 and 9 level, we've managed to get the textbook sizes into a manageable size, and we do have opportunities to even make them smaller, because our publishing is getting tighter. You know, sometimes our diagrams are too big. And sometimes our answer sheets at the back of the book took up too much space, and so we are tightening those up from a size perspective, and we are very much aware of it. We appreciate all the feedback, because that's how we improve the resource. The other significant thing that we get quite a bit is, please can you differentiate between extension questions in the textbooks? So an add-on to that is, please can you grade the exercises in levels of difficulty, essentially. So I'd like to get Trisha's thoughts on that, and then I'll give my take in terms of potential. I'd also like to get Simon's take on it, and then I'll give my thoughts on the potential trajectory in that regard with the Neo series. Thanks, Celeste. Thanks, Rowan. Yes, TP, to that question, please can you differentiate between extension questions in the textbook? Can you share your thinking on that?
Okay, so I know that this is a point of where I think what is happening is that people are wanting to know. I mean, the 4 levels are, you know, there's knowledge, then there's routine procedure, then there's complex, and then there's problem solving. So they're the four levels. I think that even, and Simon would be the best really to answer this question, because it's very difficult to differentiate, certainly when you get between, say, for a routine procedure and a complex procedure, is how do you could spend hours arguing about, is this a routine, is this a complex, is this a problem solving? You know, it's such a fine line that it's actually a very, very difficult thing to be able to decide, because, you know, from one group of kids to another group of kids, and from year to year, I'm sure you all find from year to year, one year is very good, the next year is not so good. And so then what you thought was, say, for instance, a complex procedure now is problem solving for that group. And so it's a very, very tricky thing to be able to be so principled, or whatever the word might be, and saying that these are routine procedure, these are complex procedure, these are problem solving. So that's my feeling, and I do understand that, you know, the feedback is the fact that you know, what about the kids who can't do the work? But you see, the thing is there's my point is that maybe there must be something else for them to do in order in your grade 8s and 9s, because I know we don't want to label them yet that they're going to go to math literacy, but you know, it's a very, so if I was head of department, then I would have to do quite a lot of thinking about that, is how I'm going to go and help those ones, and to help support the teachers, particularly with those weaker ones, in making it not so that it's not hard for especially for the teachers, because they do become a behavioral problem. And so it's a very difficult thing, but I've digressed from there. But the thing is that we can't just go and give them only easy sums. That's my thing, is that how do you know within a class there isn't a kid who suddenly will blossom, do you know, and then they've only been restricted to seeing a certain level of mathematics. Therefore, how do they get from that to the next level? They've got to be given an opportunity to see all types, I think. We discussed this at length, is that I would hate to categorize in class, this is this, because then as soon as you're saying that, then the kids can go immediately, they're so quick, as you know, with children. Oh, well, ma'am, we can only do those kind. And that's not what we want. And so, I think you'll be surprised if you expose the kids, and you even sometimes you just say, don't tell them how difficult it is, and you walk around and you see they can do them. You'll say, do you know that was a hard sum? And then they get surprised. Oh, I could do it. So it's,
Yeah,
so that's why I don't really like
a big psychological element to it.
Yes.
Yeah, Simon, I'd love your insights on that.
I think it's a webinar on its own, to be honest with you. The whole thing around levels and complexities of questions. But I mean, I go back to our school days, and I remember there was in the classroom mathematics, you used to get questions with the double star next to it, and you knew that was going to be an absolute.
Yes.
And almost it was psychological. You wish, or maybe I shouldn't even engage this. Maybe there's something I don't know about this. And one of my principles has always been, I want to keep the math simple, but the thinking hard. And I think with those level 4 questions, I've always loved a way where the opening little, I don't like scaffolding, I must be honest, but we have to sometimes. But in classroom, it's quite nice to have an opening sort of, I don't know how to put it, like a part A where it just gets them into the question. It actually just makes them get in. It doesn't have to have anything to do with it, but it just, they know that they're into the question. I almost want to award, and I call it not a method mark, but an engagement mark. You've actually engaged with the question. Because often with those weaker kids, or a kid who maybe doesn't have that self-confidence, they don't start and try because they've got this fear of failure. But by getting them into it and engaging with it, they suddenly realize, hang on, actually, I do know what I'm doing here. I can pull this off. So yeah, I mean, the whole thing about levels and complexity is a webinar on its own. And I do think that it's something you should probably look at doing one day. But yeah, Trish, I mean, I think like you said, the kids have got to have those skills, first of all, like let's take gradients, working out the gradient. There's your level 1. Given the gradient, working out a missing X value, we already know that's a level 2, level 3, and then using it in a question where they have to think, and it leads to a few other things. That's thinking. And I mean, you have to have the skills first before you can engage in those high level.
I agree.
So
but I've had many debates with our education team about leveling our questions, because there's a lot of demand for it. People want to know the levels of the questions, educators and learners alike. And so what we've currently done in terms of our unit revision, our mixed topic revision, is our current approach is we must give a continuum of difficulty, starting from easy, going to hard, but we don't indicate which is easy and which is hard. So you kind of know, actually, Leslie Robertson, who's on our maths advisory board, introduced me to this idea of a continuum of difficulty, and then you know that the questions in the middle are of medium difficulty, and the questions of the end are the hard ones, and the questions at the beginning of the start are the easier ones, but you don't classify them as such. So we've done that to an extent, but it's not perfectly done, because of differences of opinion, which is fine. I'm not saying it's the right way, but we also recognize that in some instances it is helpful to know. And so, just to mention to the educators, we are actively thinking on it. And one thing I'm really excited about, which is in our technology pipeline, is that we are going to be taking our question banks. We are going to be leveling them, level 1 to 4, according to CAPS. And then we're creating a tool on the Neo Series platform where you will be able to configure a worksheet based on certain categorizations. So I want a quadratic equations revision sheet with 3 level 1 questions, 3 level 4 questions, and the machine will work through our question bank, and it'll output a possible revision sheet with the solution that then you can use contextually and according to your discretion in your context. So we do see a need for it. We're trying to enable it in a helpful way, but it is quite a complex thing, as Simon and Trish have alluded to. There are some sentiments in the chat. Sarika mentioning the test your understanding exercises of a lovely standard. It starts off easy and ends with lovely complex sums. Thank you, Sarika. We often get feedback that they're too hard, but I'm glad you're putting them of the right standard. And there's that continuum of difficulty that we aim to develop with. And then Naresh is asking, how do we help a learner who has difficulty grasping maths concepts in spite of repeated explanation?
Sure, that's a good question.
That's a very hard one. Yeah.
No, I think, Naresh, that's a great question because, and Trish can obviously back me up here somewhere. I don't know if she'll back me up or not, but or have a difference of opinion. But I often, depending on the learner you're dealing with, but I often have this battle in my mind. Do you teach the concept first and then go through process, or do you teach process and then discuss the concept afterwards? And it varies. But for a learner who's having difficulty grasping a concept, I'm assuming an explanation, sometimes you just need to do, and it's going back to some old school drill and practice. Sometimes you actually just have to keep going, drill and practice, drill and practice. And suddenly they might start to ask a question, why am I doing this? And then the explanation kind of makes sense. So yeah, I fight between the two, and it often depends on what level of class I'm teaching. But I would get back to you, I don't know what grade or what section, but if you give me that, I'm willing to put some thought to it. But it would be, for me, I would often go back to some drill and practice, maybe back to your level 1 and level 2 kind of examples that Trish is talking about. Make sure those skills are up to speed, and then take it from there. But it's a hard question because, like we know, every learner is different. So you have to find ways. Another simple one. Even I often I can't understand a kid. I'll say, what's 7 plus 9, and they get it wrong. And then I say, what's 7 rand plus 9 rand? They never get that wrong. But and I think, why is that? What is that? There must be something in that. And maybe it's a way of asking them the same question in a different way, and then seeing if they can link it. But yeah,
I love that advice of concept before process, or process before concept, because I actually can think of concepts where I've learned them each way around. I've understood the concept and then been able to do the process really well, and some where I've actually battled with the concept but then just done the process until something's clicked and the concept is crystallized in my mind. So I love that advice. Go back to drill and practice, and then hopefully the concept will click later down the line.
It's old school, but it does work.
For sure. TP, any last words from your side?
No. So thank you to those who attended. Yeah, and I hope it's been helpful in many ways and quite diverse. So I think that it was excellent having Simon here. I just thought that was just the most fantastic beginning to our session. And and I just wish every single teacher, I just wish you lots of luck. And I'm sure that the reason why we all stay in this game is that there is a lot of a lot of I'm missing a word. I think I'm getting senior, very senior here. And
it's rewarding.
That's rewarding. The word I wanted. It's so rewarding. And I think that's the most important thing, is if it can keep being rewarding for you, then it's just the most fantastic thing to do. Yeah.
Awesome. Thank you, TP. Thank you everyone for joining us. It is around about 5 o'clock, so we're going to look at rounding up. Simon, thank you so much for your time. It was wonderful having you on and for sharing all of your knowledge.
Thanks to you guys for having me. I really enjoyed that. And thank you.
Great.
Thank
you everyone for joining us. All of the best with term 3, and please reach out to us if you have any feedback on the session or something you'd like to see in the next one. That would really be fantastic. But from us here at Advantage Learn for this afternoon, it's have a good afternoon and a lovely evening. Thank you, everyone.